Okay, circle the correct answer for each of the following statements. So it says the gradient of the line 2y equals 4x plus 3 is one of these. And this goes back to what we've learned on straight lines. The general equation, if you remember, is y equals mx plus c. Okay, that's the general equation for a straight line, where m is actually the gradient. Okay, so that's the value we want. The number in front of the x. Okay. However, we can't just take it as 4 here, okay? And there's no option here for 4 anyway, okay? We've got to have y equals, yeah? And the trouble you've got here is that it's 2y, okay? It's not y equals. So let's just think, how are we going to get this to be y equals? Well, if you've got 2y here as it is, that means 2 times y, yeah? 2 times y. So think about what we do then. We'll take the 2 over the other side and we divide, don't we? So we'll end up having 4x plus 3, but we divide by 2 because you times in, take it over and divide. And you're going to divide everything by 2 on this right hand side, yeah? Everything. But what I can do now is I can split up both terms. I can think, okay, 4x divided by 2 is 2x, okay? And then 3 divided by 2, well, is just 3 divided by 2 is 1.5, isn't it? But the key is here is realizing that the number then in front of the x is a 2, okay? That's your value m, that's your gradient. It says that in part B, the line 3y equals 5x minus 6 crosses the y-axis at one of these. Now think about your x and y-axis, okay? Your y-axis, okay, is this axis here. Now what's true on the y-axis? Well, wherever you are on the y-axis, if you're here, 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 anywhere, x, let's think about what the value of x is. Y can change. Y could be anything. It could be positive values here. It could be negative values. It could be 0. Okay, y can change, but actually x is 0, isn't it? X is 0. X is always 0 on the y-axis. So when this line crosses the y-axis, suppose it crosses it here, okay, y will be something, but your x will be 0. So what I can do is I can put x to be 0 in this equation. Okay, so when I've got 3y equals 5x, well, if x is 0, that would be 5 times 0, wouldn't it? Take away 6. Now 5 times 0 is 0, so I end up having 3y equals minus 6, an equation I've got now, which I can solve quite simply. And think now, to get y, you're just going to take the 3 over the other side. There's not much room here. I'll write it over here. And because you're times in here, when I take the 3 over, you end up dividing. And minus 6 divided by 3. Well, 6 divided by 3 is 2. But minus 6 divided by 3 will be minus 2. Okay, finally then, the line y equals 3x minus 2 has a point with coordinates. Okay, so basically they want to know which of these coordinates does the line go through. Let's take the last one for instance. Does it go through the last one? Well, x is 3, y is 7. Let's put it in here, okay? And x is 3. Let's see if it works. So if x is 3, okay, let's see what y comes out to be. If y comes out to be 7, we're sorted. That would be the point. So x is 3, put it in there. It would be 3 times 3, take away 2. Okay, so 3 times 3 is 9, take away 2 is 7. Oh, it works. That was lucky, wasn't it? First time lucky. Okay, so the answer is 3, 7 by substituting it. But perhaps I'll show you one that doesn't work. Okay, so obviously all of the others don't work. So if I use this one here, for instance, when x is 0, okay, if I put that in, 3 times 0, okay, x is 0, take away 2. So 3 times 0 is 0, take away 2. Y would be minus 2. Is it minus 2 there? Of course it isn't. It's positive 2. So it's not going to go through that point when x is 0. You could check another point as well. You could set x to be 2. Put x to be 2 in there. That would be 3 times 2 is 6. Take away 2 is 4. They say in 2, 3. So clearly it doesn't go through that point. It goes through that point because when x is 3, y comes out to be 7. Okay, so that coordinate satisfies it.